Hello and welcome to the next lecture. In this lecture, I'm going to discuss queue types. Before moving on with this lecture, I strongly encourage you to view the introductory session where I have explained the fundamentals of queue and simple queue. You can access it by clicking on the above link. Now let's jump into the concept of circular queue. A circular queue is a distinct data structure wherein all elements are arranged in a circular manner. Initially, the queue is full, and let's consider an empty configuration. At the beginning, we have two pointers indicating -1, meaning that the queue is empty. When the circular queue is empty, both the front and the rear pointers are set to the same index. After an element is unqueued, both pointers still point to the same index if there is only one element in the queue. However, as you enqueue more elements, the rear pointer increments to the next available position, and the front pointer remains at its original position or moves forward as elements are dequeued. The rear pointer increments and wrap around the array, and if it reaches to the end of the array, it continues from the beginning. When the queue is full and the rear pointer advances to the position right before the front pointer, it means that the queue is full, and further insertion would override existing elements, violating the queue's integrity. And now let's dequeue some of the elements. As a simple queue, we increment the front pointer to remove some of the elements. Now let's take a more detailed examination of a simple queue. In the initial state, the queue is empty. To begin adding elements, we set both the front and rear pointers to -1, signifying an empty queue. Upon adding the first element, these pointers now point to the initially added element, as there is only one element present. Subsequently, for the addition of new elements, it is sufficient to increment only the rear pointer. As observed, the rear pointer increments with each addition. Now let's consider the crucial process of removing an element. This step holds significant importance. When an element is removed, it leaves behind an empty space. The key question is how to utilize this space efficiently. We know that in a simple queue, the rear pointer typically continues to increment linearly without wrapping around. If we were to increment the rear pointer immediately, the next index would be 4, not 0. But this is not feasible since we have a simple queue with a fixed capacity and linearly traversing. Additionally, in a simple queue, trying to traverse to the index 0 is not possible because we add elements from one end and remove elements from another end. This is precisely why the concept of a circular queue is introduced. Now let's get back to the circular queue. For instance, look at index 0 and index 7. Index 7 is filled with an element, therefore we need a method to access index 0. In a circular queue, to insert a new element, the rear pointer can wrap around the array. A specific formula is employed to determine the feasible location for adding an element. By utilizing the formula, we can access index 0, where 7 plus 1 equals 8, and 8 mod 8 equals 0. And this allows a seamless addition of a new element. This method provides an effective means of accessing the index and adding a new element. Now let's remove all items in the first round. Now we must access index 0 to remove an element. This highlights another advantage of a circular queue, demonstrating how we can access the first index to remove an element. The formula is straightforward. We simply add 1 to 7, resulting in 8. 8 mod 8 equals 0, allows us to access the element at index 0. Let's consider another example for adding a new item. Since the rear is currently at index 0, adding 1 to 0 equals 1. 1 mod 8 is equal to 1. We have discussed a circular queue and their advantages over simple queue. And now let's go ahead with another type of queue. Another type of queue is doubly-ended queue or DQ. Unlike the principle of first in, first out in a simple queue, a DQ allows us to add or remove items from both ends. For NQ, we have a formula to add new elements. We can increment the rear pointer to add elements from right or decrementing the front pointer to add new elements from left. And for removing elements, we can decrement the rear to remove an item from right or incrementing the front pointer to remove an element from left side. The last type of queue that we will discuss is the priority queue. First, we need to talk about their characteristics. In this type, each element is associated with a priority and elements are ordered by their key values. There are two types of priority queue, ascending order priority and descending order priority. This priority queue will arrange elements in their ascending or descending order. In this example, we have 4 elements with descending order, meaning elements with largest value has the highest priority. So in this case, we must take 90 as the highest priority. As you have noticed, the queue has 2 elements with the same value or the same priority. In this special case, if 2 elements share the same priority, then the queue follows first in, first out principle. You can implement priority queue in one of the following ways: binary heap, linked list, arrays, and binary search tree. Binary heap is preferred since it is most efficient way to implement priority queue. I hope you enjoyed this learning and thanks for watching this video.